All right, we are a minute past, so let's get started. Welcome to the Spec-tacular Game Show. Our participants today are Ted.
Hello.
Jamie. And Liudmila.
Hello.
They are all members of the OpenTelemetry organization, and they're going to help answer some questions about the spec today.
Maybe.
Oh, and ourselves, that's right, of course. My name is Tyler Helmuth, and this is...
I'm Alex, and I don't have a microphone, so...
We're going to share this one. All right, so the game that we're playing, I've got a stack of cards here that have incorrect statements about the spec, about the Semantic Convention, OTLP, op-amp, and so on. I'm going to read these. Alex is going to read his, I'm going to read mine. And as we're reading, when the contestants hear something that is wrong, they're going to click these buzzers, and they're going to answer with the correction. Whoever gets the most points, every answer gets a point, and whoever gets the most points will win. If the contestants don't know the answer, we'll throw it to the audience, and maybe one of you guys can answer.
There are a couple of folks with AMA OpenTelemetry in the audience. Yeah. They will know the answer.
That's right. Contestants, you may buzz in at any time. You do not have to wait for the prompt to be finished. We will finish the prompt for the audience, but if you know the answer, go ahead and buzz in. You must start your correction with "actually the spec says," or you can't get the points. If you don't do it with that, someone else is going to steal your answer. So make sure you're following the rules. And of course, guessing is allowed. You don't actually have to know. You just have to say the right thing. All right. Our first prompt. The OpenTelemetry Specification, acknowledging how important telemetry data is, allows the API to always consume as much memory as possible in order to ensure no produced telemetry is lost before export. Liudmila.
Actually, the spec says that the memory consumption should be limited.
That is correct. That is 1 point. Woo! It should not consume unbounded memory. Of course, it should not consume unbounded memory. The spec says that because we want OpenTelemetry to be safe to use. We want users to be able to put the SDK, the API, the instrumentations into their code and feel confident that their business logic is not going to be impacted, that it's not going to be terribly unperformant, and it's going to be able to produce telemetry. And if you really, really do care about your telemetry and you would rather consume unbounded memory, it's configurable. You can choose which one of those knobs you would rather have. So it's up to you.
All right, the next one is about signals. OpenTelemetry is made up of only 3 signals: traces, metrics, and logs. Each signal is... I heard it, yeah. Each signal represents a coherent, standalone set of functionality, and each signal is equally important. Ted.
Actually, the spec says that OpenTelemetry is extensible, and I would certainly count resources amongst what's available currently, with profiling coming soon.
That's right. There are more than 3 signals. Baggage and profiles are also signals, but they are the core of OpenTelemetry. So they define the type of telemetry Otel supports and how they're supported, and as you said, the project is extensible.
I have a follow-up question for a panel. Baggage. Baggage doesn't mentally fit with some of the other signals, traces, metrics, and logs. What makes baggage a signal?
Baggage just weighs you down, man. No. Yeah, actually, the spec says...
That baggage weighs you down.
Baggage weighs you down. Yeah.
So actually, what baggage is for building, is an extension point for people to build additional things on top of OpenTelemetry. There are other cross-cutting concerns that might want to use the same context propagation mechanism, and instead of having to rebuild all of that infrastructure from scratch so you can pass around, say, security tokens or feature flags information or something like that, baggage is an extension point that we give people to build their own cross-cutting concerns with.
It's actually fun to say that OpenTelemetry comes with a baggage.
Yeah, that's right. This is a great answer. However, Andy will get the point in the audience over here for saying, actually, the spec says.
Yeah. Fair enough.
All right, next prompt. OpenTelemetry supports tracing, which helps you visualize the path a request took through your application. An OpenTelemetry trace is made up of many pieces of information, including a name, a kind, a start and an end time, and of course its IDs. You can even add custom data to it via attributes. Jamie.
Actually, the spec says that a span has a name.
That is correct. These are all things that are on a span, not a trace. A trace is a big thing made up of many spans. A trace doesn't have any inherent properties. It is a conceptual, many different things, many different spans. We learned about a very special span today, Spanly. That was a fun talk. If you haven't seen that talk, watch it later. It's a lot of fun. And that was the correction. Yeah.
All right. OpenTelemetry supports logs and enhances them by associating the log with a trace ID and a span ID so that it can be correlated with other signals. A log always contains a body, the field that uniquely identifies it as a log, and it may also contain other attributes.
I heard it. I hear it.
Ted. I feel like we need to make it a little bit louder, but that's okay.
You can turn the buttons up.
Yeah.
Actually, the span says that the body field is optional.
That's correct. A log does not have to have a body, and a log is not defined by having a body. But Otel does let you correlate logs and traces, keeping with its core theme of correlation.
I have a follow-up question. Is there anything that uniquely identifies a log?
Actually, the Semantic Convention says that there is. You can put a ulead on the log, and it's called log.record.id, but nobody I'm aware of is using it.
Okay, I didn't know that.
Actually, the spec for this game show says that you need to start your answer with, actually, the spec says, so I'm stealing that answer.
Yeah, that's true. Luckily, the points are only for the initial prompt. The follow-up questions, there's no rules for the follow-up questions.
So I get the point. Nobody.
I will abstain.
All right, next prompt. The metric specification defines instruments, like the histogram and some instruments, for recording measurements. Metrics can be correlated with other signals via exemplars, which are recorded values that contain a trace and span ID.
Actually, the spec says that there are histograms, but some is not an instrument.
That is correct. Some is not an instrument. Yeah, metrics are complex. You may have heard some people say that OpenTelemetry's metric specification is complex, and that's fair. It is complex. But what it's representing is complex math. It does a lot of math, so you don't have to, and it has some novel ways to represent and record metrics. Exponential histograms are a very, very sophisticated instrument, or actually, I don't even remember is it an instrument or a record, the exponential histogram?
A record player,
record.
actually. It's more like a CD.
But yeah, it's a complex problem, and OpenTelemetry has really done a lot to make metrics more consumable for customers and for users.
If I only want to record some metrics and not all of them, how do I do that? It's the pop question. Does OpenTelemetry let you just record some metrics?
Oh, Ted wants to test your knowledge of the spec.
I think I'm trying to understand if you're making a joke about some, or you're asking SOME, some metrics.
Both.
Yeah. I think the answer is views. Is that right?
Yeah, and metrics-based sampling
Okay.
is actually a thing.
All right, I think we'll be asking the questions from now on, so thank you. All signals except baggage in OpenTelemetry support attributes. An attribute is a key-value pair used to add information to telemetry, such as a status code or a hostname. The key may be any string, including the empty string, and value may be any string, Boolean, double, integer, or array of these types. There it is. Jamie.
Actually, the spec says the key can't be an empty string.
That's correct.
Oh, God.
Yeah.
Yeah, it may not be any string.
It needs to be a non-null string, non-empty string. That's right.
Non-empty string.
Attributes are what let users make their telemetry interesting and personal, as we found out with Spanley again. If you haven't seen Spanley, go learn more. They have quite a legacy. With an attribute, you can add any piece of information to your telemetry. Why is the spec strict about attribute keys being non-null and non-empty? But the op-amp spec is not strict.
Yeah, so that's a follow-up question. The op-amp spec,
Because that would be
for it, but-
dumb.
you don't like empty string keys? The op-amp spec lets you do it. But yeah, you can't do that on attributes because what would that represent?
Yeah.
Who knows?
Follow-up question, is map a valid value type
Is
for
what?
attributes? Map.
I have to answer this. Actually, spec is in the Schrodinger state. So maps might be allowed in the future, but nobody knows yet precisely when and how. But I'm going to promise they will, and you can blame me if I'm failing.
Since they're already allowed in OTLP, feels like the spec could allow it too. That's how I feel about it.
You can always just set a JSON string.
You could. All right, next prompt. This one's about semantic conventions. OpenTelemetry defines semantic conventions that specify common names for different kinds of operations and data. The benefit of using semantic conventions is in following a common naming scheme that can be standardized across the codebase, libraries, and platforms. An example of one of OpenTelemetry's stable semantic conventions is the attribute name http.method, which is used to record an HTTP method on a span or metric.
I just want to hear it again. Actually, the spec says that the stable semantic convention name for the method is the http.request.method.
That is correct.
Deep cut.
The other one was the old name, and it's got a new name. And the HTTP semantic conventions were the first ones that we stabilized in OpenTelemetry. That was really exciting. And there's a lot of semantic convention work going on right now. There's a lot of stuff happening. We're getting really close to a lot more stable semantic conventions. The more stable semantic conventions we have, the less breaking changes we're going to have for producing telemetry. The more stable telemetry that's produced is going to be. I'm really excited for stable semantic conventions, Kubernetes stable semantic conventions, database stable semantic conventions. It's going to be a really big deal when those happen.
It's a major focus topic right now in OpenTelemetry JavaScript, if anyone's not aware, trying to finish migrating all of our instrumentations to the stable HTTP semantic conventions, and then working on the database semantic convention. So if anyone's interested in helping out, there should be an issue out in the repo for you to check out.
Yeah, and the spec says that some part of database semantic conventions is stable now.
Yay.
Woo!
Lots of work to do.
All right, the next thing is about OTLP. OTLP, I'm still going to read it, which stands for OpenTelemetry Line Protocol, is the protocol for encoding, transporting, and delivering telemetry data between telemetry sources, intermediate nodes such as collectors, and telemetry backends. When implementing OTLP HTTP, the request to the server only partially succeeded. The server may reply with a status code of 503 and the partial success field initialized with the number of rejected span, data points, log records, profiles.
Actually,
Do you want to hear the button?
Quack.
There we go.
Actually, the spec says that OTLP is OpenTelemetry Protocol, and there's other things wrong in this as well.
Yeah, that was
That
bait.
is correct. That was bait.
I saw it and it made me sad.
That is.
That's all. I just wanted to hear that again.
There is
Also,
another
for
thing-
partial success, you shouldn't be giving a 503,
That's correct.
That is correct. What should you give?
a 200.
That's correct. OTLP partial success is a useful feature for indicating when only some of the telemetry payload was accepted. since sending duplicate data is unwanted. Partial success ensures that no data is retried while also indicating that something went wrong.
All right, another OTLP one. OTLP supports 3 transport protocols: HTTP protobuf, HTTP JSON, and gRPC. You use gRPC for protobuf encoded data using the gRPC wire format over HTTP2 connections. You can use the HTTP protobuf for protobuf encoded data over HTTP connections, and you can use the HTTP JSON for JSON encoded data over HTTP connections. The default protocol in OpenTelemetry is gRPC.
Actually, the spec says the default protocol is HTTP.
HTTP?
Yeah.
Just HTTP?
A protobuf, sorry.
Okay, I'll give it to you. Yes, it's HTTP.
As opposed to gRPC.
We'll allow it.
Yes. Specifically HTTP protobuf, not JSON. Still very performant. This is a really cool piece of history, in my opinion, in OpenTelemetry. If you didn't know, OpenTelemetry for a long time had gRPC as the default protocol, and we got essentially user feedback that people wanted it to be HTTP proto instead of gRPC, and it was changed. We changed it in the spec because we got that cool user feedback. So anytime that you want to raise your voice, that you've got good chance that the community is going to listen, and we appreciate when users provide feedback on the project. It's very helpful.
All right. Open Agent Management Protocol, OPAMP, is a network protocol for remote management of large fleets of data collection agents. In this specification, the implementing server must accept both plain HTTP and WebSocket connections from the client. Some features that OPAMP supports are remote config management, remote package management, health status reporting, and custom messages.
You can go.
Actually, the spec says that it may accept both plain HTTP and WebSocket connections.
That is correct. The server is free to accept only one connection type, but may accept both. So OPAMP is pretty cool. If you haven't played with it, you can manage servers remotely. It's pretty incredible what you can do with collectors. So highly recommend checking it out.
Keep forgetting to move the slide.
I know we keep forgetting to show the correction.
The wrong stuff up there too long.
That's for episode number 2.
Yeah. All right, this is the last prompt of the game, and we did a bad job of keeping score, so someone's the winner. Maybe this is the deciding one. Yeah.
We're all winners.
The metric signal provides views to allow users to customize metrics emitted by SDKs. The configuration of views via the environment variable Otel metrics views gives users the ability to configure the instrument's aggregation and attributes of measurements being recorded. Liudmila.
Actually, the spec says, and I'm like 90% sure, that there is no such environment variable.
That is correct. There is no such environment variable.
Nice.
And I will add that the views being not configurable via environment variables was one of the big drivers of the configuration format definition that happened over the last 2.5 years now. So.
And if you haven't checked it out yet, configuring your SDK with the file configuration is, in my opinion, one of the best things that has happened in OpenTelemetry in the last couple years. It was game-changing for the collector, being able to configure your OTLP metrics to the internal collector metrics and logs and traces to export via the Go SDK. Incredible. Really, really highly recommend you guys check it out.
How did we even make it this far without config files?
Yeah, it's a fair question. Okay, that was the game. I didn't keep track of score. Maybe someone in the audience did. If you know who won, you can tell us later. But thank you all the contestants for playing. That was a lot of fun. And these are all the sources if someone wants to look it up. This is a QR code if you want to give us feedback. And how much time do we have? Do we have more time? What time does this end? I don't actually know.
No, you're supposed to be done at 3:45. It is now 3.
Okay. Well, I've got 3 prompts that these 3 people have seen already. But we can, if the crowd wants to play, I've got 3 prompts, 3 practice prompts. If someone wants to give it a shot.
You guys want to play? Yes.
Okay. All right, the next prompt, this is for the crowd because we've all seen it. The OTLP file exporter specification provides requirements for how data should be stored to disk. The output must be formatted using valid JSON, UTF-16 encoding, and each line must be separated by a new line character.
You have to make a funny sound.
Okay. Actually, the spec says no one should use UTF-16 encoding, and it should be outlawed, and thus it should be UTF-8 encoding.
That is correct. The answer is it should be UTF-8 encoding. When we were doing this practice prompt, Liudmila had a really good answer. The answer was, this entire statement is false. None of this is true. This is all a lie. There's no spec for it, which I thought was really funny. And if we ever do this game again, maybe we'll put a prompt in that's just total nonsense. That sounds like an actual spec prompt. That's a fun idea.
Ask ChatGPT to generate one.
Yeah, ChatGPT, please give me an Otel spec.
Sounds legit.
All right. A resource is a representation of the entity producing telemetry. Within OpenTelemetry, all signals are associated with a resource, enabling contextual correlation of data from the same source. Resources are generally added to the signal provider at initialization and can be modified through the use of the merge interface supported by all implementations.
Actually, the spec says that the current resource is not mutable, so it cannot be modified.
That is correct.
You forgot the sound.
Oh, wah.
Is that this one? Yeah, that's good. Yes, that's correct. The current spec says that resources are immutable, and if you go through the merge interface, it makes a new resource. That's the merge of the two. I would love, Ted, if you talk a little bit about resources and entities, to talk about how that's changing maybe a bit.
So the part about resources being immutable is not changing. What's changing is the ability to replace the current resource with a new resource. The backstory here is when you start up an application, there's actually this tricky little song and dance you have to do around collecting the resources, because some of the APIs you call might be asynchronous, but you don't want to block startup waiting for this stuff. But at the same time, if you don't collect all of this before the first batch of data goes out, then you'll be sending out malformed telemetry, which is also bad. So how do you, if you are at Google, how do you force Google engineers, who are famously not smart, to do the right thing? Well, what if you just say this thing is immutable? Then they would be forced to do the right thing, right? They would have to figure all of the resources out before they started up OpenCensus, which was their implementation at the time. So to make that work, right, we had this little trick of saying the resource object was immutable, and that seemed fine because why on earth would you be changing any of these values anyways, right? Like everyone knows that resources associated with a running software program don't change while that software programming is running. And this turned out to be one of those like white swan moments where for server side situations, weird edge cases around, VMs being frozen and unfrozen put aside, this is like true. But then you get to clients, right? You get to browsers and mobile applications, and it turns out their resources can change while the application is running. For example, sessions might start or stop, or the application might get backgrounded and then foregrounded. It might be put to sleep and then wake up in another time zone. So there are all these things that you would call a resource and you would want associated with all of the data coming out of the application, but they do change because clients are a little bit different from servers. But because we were so server-side focused at the beginning, we said that they were immutable. And then we've gone through a very long, lengthy soul-searching process about how to actually fix that without breaking the spec, which is coming along, finally. Join the browser SIG.
Thank you. That was very insightful. All right, last prompt. This is all I've got written. Since it is recommended that an Otel specification implementation has a global error handler to guarantee exceptions are not leaked to the user code, it is okay for the SDK to throw unhandled exceptions for its errors in its own operation.
Quack, quack. Yeah, actually the spec says it's not okay for the SDK to throw unhandled exceptions except when it's booting up. So after that, no matter what happens, it cannot throw unhandled exceptions.
Yep, that is correct. It's not allowed to throw unhandled exceptions. This is in the same vein as the very first prompt that we did. The OpenTelemetry specification tries very hard to make sure that the code that is being added to instrument your business logic is safe to add, and it's not going to crash your application, and you don't have to worry about your app suddenly stop running because it couldn't export a log or a trace or a metric. All right, that's it. That's all the prompts we had today. Thanks for playing along. I appreciate that. That was a lot of fun. If you enjoyed the session, you can leave us some feedback, and thank you, panelists, for joining us on this journey.